The moon is rusting, and chances are it's happening because of Earth. You'd say that since they're more than 230,000 miles apart, they can hardly directly influence each other in such a way, but they do actually have a special connection. The moon affects our home planet as well, and you can see it while observing ocean tides. As Earth rotates, the moon's gravitational force pulls the water on the nearest side of Earth. It creates a bulge. At the same time, another bulge forms on the opposite side because our planet rotates and it causes a centrifugal force. And then, the planet continues to rotate underneath these bulges, which is why we have 2 low and 2 high tides every day. Plus, the moon wobbles every now and then, tilts more or less, and causes changes in ocean tides. And in return, Earth's atmosphere is making our satellite rusty. Rust is that reddish substance you see on old gates or nails. Oh, and you know Vermilion Cliffs and the Grand Canyon? They also have that specific red color, thanks to rusty iron in the rocks. It forms when iron reacts with oxygen and water. Rust is common even on Mars. The planet's trademark color comes from the rust that's been there for a very long time. That's how the red planet got its nickname in the first place. Normally, you wouldn't say the moon is a place that would rust that easily since it's dry and doesn't really have an atmosphere. But a spacecraft studied the moon back in 2008 and detected spectra, wavelengths of light, that were reflecting off different surfaces of the moon. That's why it could analyze the lunar surface better. The data it brought showed that the lunar poles had different compositions than the rest of the moon. They had rocks that contained a lot of hematite. That's a specific type of iron oxide, or simply rust. No one expected that because there shouldn't be so much rust on the moon, considering the conditions there. But we know that there's some water up there on the surface of our satellite. That's why a few new theories popped out about different materials the moon could be hiding. It's possible that they formed because water had reacted with the rocks. For iron to get this rusty hue, it needs something we call an oxidizer. That's a molecule that removes electrons from materials like iron, such as oxygen. But the solar wind keeps hitting the moon all the time, and it brings hydrogen with it. And hydrogen has the opposite effect. It gives electrons to other molecules. Earth has its shield from the solar wind. It's our magnetic field. But the moon doesn't have such protection, and because of that, rust shouldn't be able to form on its surface. But this process still happens, and it could be Earth's fault. The moon itself doesn't have an atmosphere that could provide enough oxygen for iron to rust. But apparently, our planet is generous enough to donate some of its own atmosphere. The oxygen from our atmosphere travels all the way to the moon, following something called magnetotail. That's a long extension of Earth's magnetic field, which can reach the near side of the moon. That's exactly where most of the hematite was found. And during a full moon, the magnetotail blocks 99% of the solar wind, which would normally influence the moon more. It's like there's a temporary curtain over its surface, which gives enough time for rust to form. But there's still one important thing necessary for the appearance of rust: water. It's not like you can find water that easily if you decide to take a walk across the moon. Most of it is frozen and hidden in areas that always remain in cold shadows. Those spots are far away from where most of the hematite was discovered, so it's hard to tell how the water got there. But there's an interesting idea. All those dust particles that hit the moon might be freeing free molecules of water that are locked in the surface layer of the satellite. This is how water ends up mixed with iron. We don't know exactly what these dust particles consist of. They might be carrying some water too. As they hit the lunar surface, this might create heat, which boosts the oxidation process, and more rust forms. So, our planet does certain things that change the moon, but humans do the same. A probe that landed on the lunar surface back in 1959 was the first human-made object that touched the moon. That's also when we started altering the moon in unpredictable ways. Scientists call this the lunar anthroposene. It's like an analogy with Earth's anthroposene, a period when human activity made an impact on the planet. It's not like we can choose a certain starting point when such an activity began. But we now know that things we have done over the history of our existence have really changed the environment of our home planet. We don't have any people living on the moon yet, but we've already left some traces there. After humans first came to the moon, we've had many missions there. We left some landers and flags, moved lunar soil, brought golf balls, scientific equipment, and even some human waste. Plans for the future? Send more missions up there and even potentially create an infrastructure where some of us could live, study the moon's resources, and send them back to Earth. That's why it's important to talk about the lunar anthroposene to remind ourselves we have to be responsible and take care of our heritage. Many people are confused about why we sometimes see the moon during the day. Some even believe it's something new that didn't happen before, especially after they started sharing a low-res picture of what looks like a full moon in the middle of the day. Some have pretty unusual ideas that the sun isn't the same color as it was before either. Allegedly, it used to be more yellow. The sun hasn't changed its color. It's still blue-green. But it's possible that we saw it as more yellow when we were younger because before, pollution wasn't as bad. And when it comes to the moon, we can see it both at night and during the day. It's brighter at night because there's no light coming from the sun. But it's not like it goes anywhere during the day. It's still there, but we just don't see it during the new moon phase. That lasts a couple of days, and during that period, the moon comes pretty close to the sun. The scattered light coming from the sun makes our satellite less visible to us. Speaking of the moon phases, they're easy to recognize when you know what to pay attention to. First, there's the black moon, which can mean a couple of things. One definition says that it occurs when we have 2 new moons in a month. Another one claims that the black moon happens when there's no new moon in a month, and that only happens in February. A blue moon is not called that because of the color. It's the 3rd full moon in a season that has 4 full moons. And a supermoon occurs when a full moon coincides with the moon's closest approach to Earth in its elliptical orbit. That's why it looks bigger than usual. Sometimes you can look up to the night sky and see an eerily red sphere up there. It's not about signs that tell us that the end of the world is coming or that werewolves are roaming around. But yep, blood moon is a good inspiration for stories like that. In reality, it's just an astronomical event when our planet casts a reddish shadow on the moon. And that happens when Earth comes between the moon and the sun, which is called a total lunar eclipse. Earth's little companion catches some red light coming from our atmosphere, and that's why you see that specific color.
There's something happening inside the moon, something that nobody expected. Not a dramatic shift you'd see on the outside, but deep down, where things seem frozen in time, scientists have uncovered a hidden layer of what you could only call moon goo. Remember those school lessons about the crust, mantle, and core? Much like the Earth, the moon is made up of layers, a crust, mantle, and core. However, the moon's core is much smaller compared to ours. Earth's core is huge. It makes up about 1/3 of our entire planet's mass. The moon's core makes up only about 1 to 2% of its mass, and its diameter is about 1/5 the diameter of the moon itself. It's surrounded by a hard, rocky mantle. But it turns out that between these 2 layers, that mysterious goo layer, and it's way more important than you might think. The layer is soft and partially molten, ebbing and flowing like the tides in our oceans. It rises and falls, stretching and shifting as if it were alive. Its movement isn't chaotic, but subtle and regular. We always knew that the moon influences our seas and oceans, causing tides with its gravity. But it turns out that we influence it back. The goo ocean reacts to the gravitational dance between Earth and the Sun. Also, the molten layer could be made of ilmenite, a very intriguing material. Ilmenite is rich in titanium, a strong and lightweight metal that we really love over here on Earth. Titanium is used in everything from airplane parts and spacecraft to medical devices. even in everyday items like bikes and laptops, all because it's incredibly strong and very resistant to corrosion and heat. So, if the moon might have a molten layer rich in ilmenite, that would be awesome. Astronomers are already planning for lunar bases, and if we had a material to build structures, spacecraft, or even tools for astronauts right there, that would be a game changer. Otherwise, we'd need to transport materials from Earth, which is extremely costly. This is our first tangible sign that the moon is not just a cold, boring rock. Instead, it's dynamic, living, and breathing, with moving forces beneath the surface. NASA used new special tools to discover this: the Gravity Recovery and Interior Laboratory and the Lunar Reconnaissance Orbiter. These are both space missions designed to study the moon, but they don't just look at the surface like a telescope. Instead, they help measure things we can't see with our eyes, like the moon's gravity and how it changes over time. Grail sent 2 small spacecraft around the moon named Ebb and Flow. Clever. The idea was for these spacecraft to fly close to each other and measure tiny differences in the moon's gravity as they go. It's like they were feeling the moon's invisible pull in different places. If the moon's gravity was stronger in one spot, the spacecraft moved closer together, and if it was weaker, they moved farther apart. This helps scientists understand what's going on inside the moon, even if they can't actually go there. And the spacecraft intentionally crashed into the moon in December 2012 to end the mission. The Lunar Reconnaissance Orbiter is a bit different. It takes super detailed pictures of the moon and collects other important information about its surface. By combining the information from both Grail and LRO, we were able to find this goo layer. But this discovery actually challenges everything we thought we knew about lunar geology. How did this molten layer get there? How long has it existed? And perhaps more fascinating, how it stayed warm for millions of years? That's some million-dollar questions. The moon's core generates heat just like ours. But it's not as easy as saying, oh, the core's heat probably keeps it warm and molten. Well, first, the moon's core is much smaller and less active than Earth's, meaning it produces significantly less heat. Plus, the moon is much cooler than Earth in general. With temperature dropping to minus 200 degrees Fahrenheit on the surface, how could this inner layer still stay in this flowing state? That's still a mystery. In any case, this goo could actually explain a lot of stuff about the moon. For example, astronomers were exploring moonquakes and how they happen. Now they think that it might be this semi-molten layer shifting and moving beneath the surface. Now, beyond the moon itself, it also tells us more about other celestial bodies. If the moon, something we considered basically a huge static rock, has such a dramatic life, what about other planets, moons, or asteroids? Could they also hide similar hidden movements beneath their surfaces? We can even understand our own planet better, learn more about how tides and similar stuff works. There are so many great discoveries we've been making on the moon. Recently, we found some awesome stuff beneath the surface, massive caves hidden for millions of years. For over 50 years, scientists have suspected that the moon's surface is full of underground tunnels and caves. These are known as lava tubes because they were formed by lava. Duh! Millions of years ago, the moon was pretty unstable. It underwent some volcanic activity, causing eruptions. When a volcano erupts, lava can flow across the surface. As the outer layer of the lava cools and hardens, it forms a solid roof of dark material. It's actually what these famous dark spots on the moon are. These are dark, hardened remains of ancient lava. But the hot, molten lava continues to flow through the center. Once the eruption ends and the lava drains away, what's left behind is an empty hollow tunnel, hence a lava tube. On Earth, we have lava tubes in places like Hawaii or Iceland, where volcanic activity has created similar underground tunnels. The same thing happened on the moon billions of years ago, although they're much crazier compared to ours. In fact, lunar lava tubes are now thought to be some of the largest and longest in the entire solar system. One such cave was discovered beneath the famous Mare Tranquillitatis, the place where Apollo 11 first landed, and it's at least 340 feet deep. Now, all these lava systems have remained hidden just beneath the surface, untouched for millions of years. Only now, they finally managed to prove their existence. Scientists from the University of Trento in Italy found them using special radar technology and advanced computer methods. These techniques let you see underground by sending radar waves. The waves bounce back and give clues about what's hidden underneath. By analyzing the way these waves reflected back, the researchers could detect the shape and size of the hidden caves. Now, the best thing about this discovery is that we could build all our bases there. These caves protect from radiation, harsh winds, and meteoroids. NASA even found evidence that some of these caves stay at a steady 63 degrees Fahrenheit. That's some crazy coziness for the moon. And on top of that, there could even be some water there. So humans could take shelter inside these natural tunnels and build entire colonies on the moon. And I know what you're thinking. Could unexpected lunar monsters hide deep in those caves? Well, sure. There's a huge potential for exploring these caves and finding some awesome stuff. But even if we manage to find a miracle, like small life or microbial organisms, there's a 99% chance that there won't be actual animals or monsters. It would just be impossible for them to develop in such conditions. But it would make a great horror movie. Researchers want to send robots or drones to explore the tunnels first, and then see if they're safe enough for humans. And it's not just the US getting in on the action. China is also investigating the possibility of using these moon caves as a future base, showing that the race to explore and settle the moon is heating up.
Recently, Chinese scientists discovered something interesting on the moon, an unusual crystal. Moreover, they found out that this crystal contains an element that can literally replace nuclear fuel. Let's find out more. The composition of the moon has long remained a mystery to us. Half a century has already passed since the Apollo mission. Unfortunately, we haven't traveled to the moon much since then. So it's not surprising that it's not so easy for us to study it. But recently, we've made a breakthrough in this area. In December 2020, Chinese scientists sent the Chang'e 5 probe to the moon. The mission was named after the ancient Chinese deity of the moon, Chang'e. Quite poetic, isn't it? Anyway, after the probe went to the nearest side of the moon, it spent several days digging through the surface and rocks and then returned to Earth. In total, it collected about 4 pounds of various lunar rocks, like basalt, solidified lava, and so on. And yeah, maybe it doesn't sound too impressive, but it's actually a mini breakthrough. After all, we hadn't received any lunar samples since 1976. And these samples are very important for learning the history of our world. We've been struggling for many years to find out, for example, how the moon was born at all. Yes, there were a lot of theories, but we still couldn't find any proper evidence for any of them. But thanks to the latest missions and some computer simulations, scientists finally found out the truth. The moon was born when some random dwarf planet crashed into our Earth many millions of years ago. This dwarf planet was slightly smaller than Mars. The fragments of the Earth went into space, but some of them stayed in our orbit. Then they stuck together and formed the moon. It sounds horrifying, but in reality, the birth of the moon was the best thing to ever happen to our planet. If it weren't for this beautiful satellite, all our oceans would be small puddles. Life wouldn't have appeared on Earth at all. So this is already an amazing discovery. But that's still not all. Studying the collected rocks, scientists from the Beijing Research Institute discovered something unusual, a rare lunar crystal. Looks pretty boring, doesn't it? Just some tiny transparent monocrystal about the thickness of a human hair. We've already found such things on the moon before. These crystals were formed as a result of volcanic activity, just like some garnets on the Earth. And yep, the place where they discovered these crystals also suffered from volcanoes 1.2 billion years ago. That means that this tiny baby is over 1 billion years old. But that's not the most important thing. It's the fact that this crystal is made of a unique material, the one that we've never seen before. Researchers from the International Mineralogical Association have confirmed that such a composition can't be found anywhere on Earth. The crystal was named Chang'e, again after the same moon deity. And this is another achievement. This is the 6th previously unknown mineral that we found on the moon and the first one found by China. Now, it has become the third country in the world to make such a lunar discovery. However, this tiny crystal still wasn't the only remarkable thing they found. After studying this gem and about 140,000 other lunar particles, scientists have discovered something else. They found helium-3. Why is it so important? Because this is one of the elements that feed the sun and other stars in our universe. We tend to say stuff like, "Put out the sun is burning," and so on. And this is one of the reasons why many people actually think that the sun is a huge fireball. But it's not. Its burning is actually a completely different process, which is called nuclear fusion. The process itself is quite simple. During this reaction, hydrogen in the star turns into helium. But this simple process is actually one of the most violent and insane reactions in the universe. There's a real boiling broth of particles inside the sun. The hydrogen nuclei that jump and rush there are constantly repelling each other since all of them are positively charged. And so they could continue to boil and chill around without bothering anyone if it weren't for the stars. The stars turned out to be cheaters. They have such strong gravity that they basically grab billions of these little atoms and squeeze them together. Combining with each other, these atoms create new heavy elements, like the mentioned helium. And when this happens, they throw a lot of energy into space. And that's how the sun burns. At the same time, it spreads so much energy that we can't even imagine. Okay, so what is helium-3? Well, this is an element to which even the sun can say, "Whoa, dude, you should calm down." The fusion of helium-3 atoms releases even more energy than in typical nuclear fusion. And most importantly, it doesn't pollute the atmosphere with harmful things like radiation. We have very, very little helium-3 on Earth. Its prevalence in our atmosphere is about 1 in a million. And besides, it's constantly trying to escape from us back into space. Probably feels some bad vibes from us. However, scientists have recently found out that there's a place that contains a lot of this element. Yep, you guessed it, it's the moon. We think that there's more helium-3 on the moon than on Earth because of the solar winds. The sun has been hammering on the moon with its helium-3 for billions of years, so now it's all over the place. It's still not too much if you compare it, for example, with Jupiter or Saturn. But don't forget how much energy it can release. For your information, with only 25 tons of helium-3, it's possible to provide America with energy for an entire year. Now, there are 35,000 tons of it here on Earth, and more than 1 million tons on the moon. Only these sources could feed the entire US for thousands of years. So basically, in the future, helium-3 may become a new source of fuel. And it's better than nuclear fuel in basically everything. Helium-3 won't leave any harmful waste and radiation. It's more powerful and not that dangerous. In other words, this environmentally friendly and efficient energy could be a revolution for our planet. Sounds cool, huh? So, what are we waiting for? Grab the shovels, you might say. But there's a little problem here. Unfortunately, we haven't yet come up with anything as wildly strong and hot as the stars. To use helium-3, we need crazy temperatures and pressure. We need a thermonuclear reactor, and we have no idea how to build it, yet. And even if we could heat it up to such temperatures and get the needed pressure, we still don't really know how to handle helium-3 correctly. Therefore, even if we have an infinite amount of helium-3, we still won't be able to use it. But still, there's a great power behind helium-3, so it's not surprising that different countries have already started a race for nuclear resources. Now that Chang'e 5 has discovered a new helium-3 deposit on the nearest side of the moon, this race can become downright global. For example, China already plans a new lunar mission in 2024, Chang'e 6. During this mission, they want to collect the first samples from the far side of the moon. As you can see, finding this lunar crystal was very important for us, these crystals can help us find new ways to create helium-3. And if we manage to do that, humankind will enter a new era. But to do this, we still have to solve a number of problems. How to deliver a bunch of these lunar crystals to Earth, how to make them produce energy, and so on. Let's hope that in the future these issues will be resolved and we'll find a way to produce clean, safe, unlimited energy. Look at these two pictures. At first glance, one might think, well, aren't they showing the exact same thing? Truth is, they don't. But both these subjects are some of the most complex structures humans have ever had the chance to study. The first image shows a cluster of galaxies from our universe. The second is just a small neuron in the human brain. After seeing these images, some were quick to compare them. Is the universe nothing more than a huge brain? Now let's not get too excited. Before we go into describing all the similarities between the universe and the human brain, there is something we need to be aware of. It's a little thing called apophenia. And it's when our brains make up similarities between two objects that are seriously unrelated. The best example is when we look at clouds and start to see all sorts of cute animals and weirdly shaped objects. We might be doing the same thing when looking at those two initial pictures. Maybe it's just our brain making up similarities where there aren't any. Some scientists became fascinated with this huge brain universe idea. They wanted to make sure it was not just a weird coincidence. There had to be a way they could measure how the universe compares to the mushy organ inside our heads. So they started with the brain. It's probably one of the most complicated things we know in the whole universe. That's because it's packed with more than 80 billion neurons. These cells are responsible for taking information from our senses and sending out messages all over our body. Try to think of neurons as workers in a factory. They don't just do their work, they actually communicate with each other, thanks to these elements called axons and dendrites. The axons are responsible for carrying electrical signals away from the neuron's body to other neurons or muscles. Dendrites, on the other hand, have the task of receiving that information. All of them together make this mega network of about 100 trillion connections. The universe is one big social network itself too, but this time it's made up of galaxies. You might picture the universe as stars and planets with a ton of empty space between them. It's not quite right. What we can see and measure is known as the observable universe, and it's really vast. Think about 90 billion light-years across, containing hundreds of billions to maybe a few trillion of galaxies. These galaxies, like the one we're standing in at this very moment, are bundled together in groups. Our Milky Way is friends, in a way, with galaxies like Andromeda and Triangulum, and altogether, they're a family called the Local Group. This family of galaxies is part of an even bigger bunch called the Virgo supercluster. From what we can tell, the space between them might not be empty. It's filled with these threads made up of regular matter, but there might also be this mysterious dark matter doing its thing. Scientists didn't stop there. They decided to take it a bit further. They started by examining thin slices of the human cortex, the part responsible for our thoughts, memories, and even our consciousness. The next step was to compare them with equally thin slices of the universe from a computer simulation. Now it's obvious there's this enormous size difference between the brain and the universe. But the way they looked at it kind of made them somewhat comparable. As they zoomed in, think 40 times magnification, these scientists began noticing that the structures were very much alike. At this zoom, the brain's neural network looked like the universe's galaxy clusters. To make sure they weren't just imagining things, they used two clever methods. The first one looked at how these networks connected and how densely packed they were. They noticed that the middle part of a neuron, or its nucleus, is way tinier compared to its connecting fragments. Likewise, galaxy clusters are tiny when you look at the super long connecting threads between them. The second method was about checking how organized these networks were versus just being random. They looked at how everything was structured around each connection point, whether it was a neuron in the brain or a galaxy cluster in the universe. The resemblance doesn't stop there. We know that our brain is mostly water, about 70% to be precise. Now, the cosmic web in space, it too has about 70% of something, only this time it's dark energy. Water and dark energy may not be the most important elements in each of their structures, but they might still play a part in how everything sets up. The analogy continues. You see, the space we'd need on a computer to map out the universe is almost the same as our brain's memory storage. Somewhere in the ballpark of 2.5 petabytes. So theoretically, a chunk of the universe could fit in our brains. Or flip that, and our entire life's memories could get stored in the universe's network. There are differences too, and we have to be aware of them to make sure we're assessing things properly. For starters, the universe is pretty much the same all over. It doesn't change its composition that much, regardless of where you travel in the observable area. But our brain, not so much. Different parts have different jobs. Also, our brain connections send information depending on things like what you're seeing or touching. On the flip side, the universe's links are just energy. There's also a difference between how these two structures came to be. It turns out that the patterns we see when we're gazing up at the stars are all shaped by gravity and some weird unseen force called dark matter. Massive fireworks in space called supernovae can also affect this cosmic wallpaper. On the opposite side of the spectrum, our brains got their shape from evolution. That long process where animals, including us, get to pass on the best features and data they've learned to their offspring. So, if a trait like a certain shape of the brain helped our ancestors dodge a hungry tiger, that trait got passed down. Our brains are also built the way they are because they're supposed to act like a superhighway for our thoughts. Quick thinking was crucial for people back in the day when they needed shelter from wild animals or the elements. Now, especially if you're a fan of sci-fi literature, you might be wondering, if the universe is like this immense brain, what might its body look like? We might as well be living in someone else's head. We like to think of humans as evolved, intelligent, and at times, hard to understand creatures. But what if we're just tiny neurons in a larger, more complex structure? Well, for the time being, we can only let our imaginations run wild. There's no way we can test at this point what's outside our universe. By all means, we don't even know how large it is. By looking at the parts we can see, the estimations are that the universe is about 95 billion light-years in diameter. Even if we'd somehow manage to travel at the speed of light, though that seems a bit impossible at the moment too, it would take an enormous amount of time to reach those supposed edges of the universe. There's also the theory of the multiverse. We don't have much tangible proof of this idea either, but it does claim we live in a universe out of many. Ours has time and space. Other worlds may have different rules and components. Life may look differently out there in ways we can't even understand. Having a better understanding of the universe is just as important as figuring out our brains. You see, we still have many unsolved mysteries right here under our noses, or behind our noses to be more precise. There are a lot of things we've yet to figure out about the human brain, like how we store and retrieve memories. We know that each time we learn some new piece of information, our brain changes. But we don't have the entire process mapped out, and it looks like it might take a while before we fully understand it.
Recently, scientists have discovered a humbling collection of monster galaxy superclusters, 662 in total. One of them is so ginormous it can make anyone terrified. It's called the Inosto supercluster, and it's located 3 billion light-years away from Earth. This particular supercluster was called after an Estonian astrophysicist who was one of the discoverers of the large-scale structure of the universe. This supercluster is truly staggering in terms of size and mass. Its mass is the same as that of around 26 quadrillion suns, which is 26 followed by 15 zeros. The galaxy supercluster is so huge that it would take a light signal 360 million years to travel from one side of it to the other. The rest of the discovered superclusters can't measure up to the Anostos supercluster, and still, they are no slouches in the size or mass department. Using the discovered sample, a team of researchers led by astronomers from Tartu Observatory managed to calculate the average supercluster size and mass. It turned out that the typical mass of a supercluster in that collection was about 6 quadrillion solar masses, and the typical size of a supercluster was around 200 light-years across. It means that the average supercluster is more than 2,000 times larger than our home Milky Way galaxy. Another comparison for you. If the Sun had the same mass as a golf ball, a supercluster would be as massive as Mount Everest. During a closer examination of the properties of these superclusters, astronomers found out that galaxy clusters within these superclusters are heavier than those found outside the superclusters. It proves that galaxies in such superclusters grow and develop in a different way from galaxies elsewhere. But even though the superclusters have tremendous masses, individual galaxies they contain seem to be less dense than others. Most likely, it happens because this insane mass is spread across huge volumes. At the same time, supercluster galaxies are dense enough to have a tremendous gravitational effect on the matter filling the superclusters themselves, including their dark matter content. This matter is invisible to human eyes since it doesn't interact with light. Astronomers hope that the supercluster discovery will help us not only better understand how such vast collections of galaxies come together, but also allow us to figure out the answers to the mysteries of dark matter and dark energy. Our universe consists of normal matter, and dark energy. Normal matter, which is everything you can see with your own eyes or with the help of instruments, makes up around 5% of the universe. Dark energy takes up around 68%, and about 27% of the universe is dark matter. Now, dark energy is believed to be a force responsible for the expansion of the universe. Astronomers wouldn't even know the thing existed if, several decades ago, they hadn't found out that the expansion of the universe wasn't slowing down. Quite the opposite, it was accelerating. It meant there had to be some enigmatic force counteracting gravity. It was dubbed dark energy. As for dark matter, it is supposed to explain how objects work together. Potential candidates for dark matter vary from strange particles to super-dim objects. The European Space Agency's Planck satellite even helped astronomers calculate how much dark energy the universe has to contain to explain the way its expansion is constantly speeding up. But let's get back to our superclusters. The most curious thing is that the team behind the discovery has noticed that galaxies in these superclusters seem to be separating at lower expansion speeds than expected. What it means is still unclear, but hopefully, studying the superclusters will help us figure out the mystery of these troubling discrepancies observed in the universe's uneven rate of expansion.
The Big Bang Theory doesn't explain how exactly our cosmos started. It's more like a story about what happened after, in the earliest stages of the universe. That's when all stars, galaxies, and specks of dust were crammed into a dot, no bigger than a peach with a temperature of more than 1 trillion degrees. Our cosmos doesn't have an edge or outside. The Big Bang wasn't an explosion that happened at some particular point. It was the moment when space itself began to expand everywhere at the same time. That's a process we call inflation. When the cosmos was nearly 1 million times smaller than today, everything was just a plasma that later expanded, cooled, and then converted into a neutral gas. That was the time when the first atoms formed. All these processes released enormous amounts of radiation. The cosmic microwave background, CMB, is the fossil of that radiation that dates back to about 380,000 years after the Big Bang. Before that, the heat from the creation of the universe was way too intense for even light to shine. Only after matter cooled down did it get lighter because the universe became less dense and more transparent. In the first 3 minutes of this process, certain light elements formed, such as hydrogen and helium. About 400 million years after the Big Bang, the cosmos slowly started coming out of its dark ages. This period probably lasted over 500 million years. Clumps of gas came together and formed something beautiful, the very first stars and galaxies. All this gave off lots of ultraviolet light. It was as if someone finally turned on a cosmic flashlight that cleared away the foggy gas that was all around. About 9 billion years later, our solar system got into the game too. It was born from this dense cloud of interstellar dust and gas. The cloud fell apart, possibly because of the shockwave produced by a star that exploded somewhere nearby in a spectacular supernova. This left us with a solar nebula, a disk of material that kept spinning. At its center, gravitational forces kept pulling more and more material in. At one moment, the pressure at the core became so great that hydrogen atoms started to mix and form helium. Like it happens with other processes in space, this released giant amounts of energy. And ta-da, we got our star. So big that it makes up over 90% of all the matter in our solar system. The remaining matter from the disk had its own job to do. It probably started off as grains of dust even smaller than the width of your hair. Gravity and other forces made clumps smash into one another. They got bigger and bigger. Particles of dust eventually evolved into pebbles, and then, as this donut-shaped disk of gas kept spinning, they turned into rocks. Meanwhile, the star pulled in nearby gas and pushed the rest of the material farther away. Those parts of the disk were far away from the sun, so water in those regions started to freeze. Soon, there were tiny pieces of ice flying around, gathering into dirty snowballs that became planetary cores. Since it was cold, gas molecules could slow down enough for a planet to draw them closer. That's how we got our famous gas giants, Neptune, Uranus, Saturn, and Jupiter. Jupiter and Saturn probably formed first, maybe even within the first 10 million years of the existence of our solar system. Parts of the disk that were closer to the sun remained warm. The material there gathered into rocky planets. After the icy giants appeared, not much gas was left for the other ones though. So, Mercury, Venus, Earth, and Mars ended up a bit smaller. They may have taken tens of millions of years to form after the sun was born. This is, of course, a very simplified version of how we got 8 planets in our solar system. Who knows if we'll ever know the whole truth? Time went on. Space debris was swirling around. Some objects became large enough for their gravitational force to shape them into spheres. That's how we got dwarf planets and big moons. Our asteroid belt is the region that separates inner planets from outer ones. It's full of pieces and bits from the early solar system that never grew into something bigger. They just kept on floating around, maybe waiting for another chance. Other smaller leftovers turned into comets, meteoroids, asteroids, and small irregular moons. 4.5 billion years ago, something else arose from all that chaos. A planet almost as big as Mars collided with Earth. And the debris formed the only moon we have today. Somewhere around that time, the Sun also got to a new level. At its younger stages, it was just a ball of helium and hydrogen that still wasn't powered by fusion. Over millions of years, it got hotter and more pressurized, and finally turned into the shining star we know today. It's supposed to stay like this for a very, very long time. Around 10 billion years. Simulations scientists have made to understand the creation of the universe show that the chaos of that time was even bigger than we thought. Orbits of the giant planets probably shifted during that period too. The gravitational force from many objects in the Kuiper Belt shook Saturn and Jupiter into a 2-1 resonance. That means Jupiter made a circle around the Sun twice for every Saturn orbit. This brought the two giants closer together, which wasn't good for their surroundings. There's a theory that Uranus didn't form where it is today, which is 20 times farther from our Sun than Earth. At this distance, there wasn't enough material to make the whole planet. That's why there's an idea that Uranus was born closer to the Sun before it got ejected farther away for some reason. Maybe that reason was the mess Jupiter and Saturn made. Some believe Neptune shares a similar destiny, together with the whole Kuiper Belt. As Uranus and Neptune were passing through the Kuiper Belt, they scattered most of the objects there. Any additional ice planets that had formed there also ended up kicked out, but in this case, entirely out of our solar system. Pieces of these scattered worlds that were located more outwardly stayed in the Kuiper Belt and the Oort cloud, a faraway sphere of ice bodies where the majority of comets come from. In all this chaos, the inner planets got hit. Scientists think that's how we got organics and water here on Earth. That's exactly what we needed for life to start developing, somewhere 3.8 to 3.5 billion years ago. We found evidence of microbes in the hard structures they made. Those are called stromatolites. They help us understand the earliest forms of life on Earth. Up until 3 billion years ago, Mars might have also been a good place for life. The red planet used to have a thick atmosphere and a strong magnetic field, just like Earth. But unlike our planet, Mars cooled from the inside, which switched off this whole mechanism. Without its magnetic field, nothing could protect the planet from the solar wind that pulled away most of its atmosphere in just a few 100 million years. Mars used to have magnificent lakes, rivers, and water streams that left traces we can see on its surface, even today. Luckily, Earth managed to keep its water, so life continued to evolve. 2.5 billion years ago, Earth got photosynthetic organisms that started pumping oxygen into the atmosphere and helped create the entire animal and plant kingdom across the planet. Another big thing happened in our solar system later. Saturn got its astonishing rings. No one knows for sure what happened back then, but a new theory says the rings aren't as old as the planet itself, only about 100 million years old. At the same time, something hit our moon and left Tycho crater, one of the most prominent craters on the lunar surface. Other planets couldn't avoid collisions either, including Earth. You already know what happened 66 million years ago. A giant asteroid triggered changes in climate and erased 3/4 of life, including dinosaurs.
You're traveling through deep space, circling stars and entire galaxies. Whoa, looks like this multicolored nebula will soon collapse under its own weight and explode like a supernova. Now let's carefully circle this black hole. Try not to get caught in its gravitational field, or it'll swallow you like a space monster. Wait, what's that strange structure right there? It's a glowing wall. And if you look closely, each glowing dot is an entire galaxy. That wall has about 100,000 of these galaxies. The Milky Way has 100 billion stars. So this wall holds a quadrillion, that's 10 followed by 15 zeros, of stars like our sun. This giant structure is called the South Pole Wall. It's located about 500 million light years from Earth. By comparison, the closest star to our home is Proxima Centauri, and it's about 4.2 light years away. Rockets can cover that distance in about 73,000 years. So the journey to the South Pole Wall may take longer than our solar system exists. And this wall is simply gigantic, even on a cosmic scale. It's about 1.37 billion light years long. To give you an idea of how large that is, the Milky Way is only 100,000 light years wide. But you can't see this wall even with the most powerful telescope. The problem is that the Milky Way itself obstructs your view. It's so bright that it's hiding this wall. It's like trying to look at the starry sky in a metropolis. The light pollution won't let you do that. Scientists have been able to detect this galactic wall by measuring redshift. We know that all objects in the universe are moving. They spread out from each other as a result of the Big Bang, which happened billions of years ago. And when galaxies move, their light waves change slightly. By measuring this change, we can understand what the object is and how it moves. And this wall isn't even the largest in our universe. This is the Hercules Corona Borealis Great Wall. It's a giant flat superstructure about 10 billion light-years wide. That's around 10% of the entire observable universe. And it's also a wall. That is, a cluster of galaxies. We were able to detect this giant structure by gamma ray bursts. It's the brightest electromagnetic event in the universe. You could even see it in the far reaches of our universe. Such bursts are a very rare event. In the Milky Way, for example, it happens once every few million years. If we notice many such bursts in a short time from the same place, it means that there are many objects like the Milky Way in that place. So, there are a lot of galaxies out there. Another unusual giant structure in the universe is the Huge Large Quasar Group. It's about 4 billion light-years across. So, it takes a photon of light almost as long as our planet has existed just to get from one side of the structure to the other. And if you put the Huge Large Quasar Group on the scale, it would be 6.1 billion times heavier than our Sun. Scientists have found that there are at least 73 quasars in that structure. These are some of the most unusual objects in the universe. They are the active cores of galaxies. At the center of a quasar is a supermassive black hole. This giant eats up the matter around it. A wild force of gravity twists the matter around the black hole, forming a disk. And this disk is the source of the strongest radiation out there. By comparison, the radiation from a single quasar is tens or hundreds of times stronger than that of all the stars in our galaxy put together. Because of such strong radiation, we can detect quasars, even at very long distances. That's why they're also called beacons of the universe. Scientists use quasars to study the universe and the movement within it. One of the most distant quasars from us is about 13.1 billion light-years away. This makes it one of the oldest objects in the universe. It appeared about 690 million years after the Big Bang, and it's almost 3 times older than our solar system. It's still glowing with extreme brightness, about 4 and 14 zeros times brighter than the Sun. Scientists explain that at the center of the giant is a supermassive black hole, 800 million times heavier than the Sun. All these giant structures are just building blocks of our universe. Look, this is our solar system. Now, zoom out a little, and this is where our home star is in the Milky Way galaxy. Zoom out again. Here's a local group of galaxies. All the bright spots here are galaxies. Here's Andromeda, and here's the Triangulum galaxy, plus a few dozen other slightly smaller galaxies. They're all gravitationally connected. The size of this structure is about 10 million light-years. That's 100 times the width of our galaxy. Zoom out, please. This one is the Virgo supercluster. It's 20 times larger than the local group. There are about 30,000 different galaxies, and the mass of the whole thing is about 1 in 15 zeros solar masses. Zoom out again. Laniakea. This structure is almost 3 times larger. It includes the Virgo supercluster and other smaller clusters. And there are about 100,000 galaxies here. It's not over yet. Zoom out one more time. Here's the Pisces-Cetus supercluster complex. This giant galactic structure contains about 60 clusters of galaxies. So there are more galaxies in it than grains of sand in the desert. You know what to do. Zoom out! Phew, this is the observable universe. There are over 500 billion galaxies. And the stars? Well, there are about 1 billion trillion stars. The observable universe has its own structure. Clusters of galaxies form chains and walls, as you've seen before. But these strands are separated by huge regions of absolute emptiness. These areas are called voids. In these places, there is no matter at all. There are fewer molecules in the voids than in an empty room. One of these voids has a very mystical reputation. It's the Eridanus supervoid, or the cold spot. It appeared here only 380,000 years after the Big Bang. It's almost 1 billion light-years wide and could hold hundreds or thousands of galaxies with trillions of stars. Some scientists believe that this cold spot may have been the result of the largest collision ever, a collision of universes. There's a theory that our universe is some kind of bubble, a huge sphere that contains all these walls and chains of galaxies. Now imagine that there's an infinite number of these bubbles. They could be parallel worlds or different universes. Many years ago, one bubble came close to the bubble of our universe. Their walls touched, and the two universes connected for a while. It's like two drops of water coming together. But that universe kept moving. The area where the bubbles joined became thinner and thinner until that connection broke, and the two bubbles detached from each other. At this point, the second universe ripped some of the material out of our bubble. All those galaxies that used to fill the Eridanus supervoid ended up in a parallel universe. Scientists supposed we might travel through other bubbles. Flying to the supposed wall of our universe would take forever, and then it would take even longer to fly through inter-universal space. So we have to use portals or wormholes. Here's how it works. Imagine a piece of paper with point A on one side and point B on the other. Instead of moving all the way across the sheet of paper, we just fold the sheet so that point A is right above point B. All that's left to do is make a small hole, and the journey takes only moments. Some scientists believe that such shortcuts through universes lie inside black holes. But how do you survive falling into a black hole? You just have to pick one that's big enough. It's all about gravity. Imagine you're falling into a black hole right now. The closer you get to it, the stronger effect it has on you. It intensifies with every inch. At one point, the gravitational force that affects your head is much stronger than the one that affects your feet. Then you turn into spaghetti. Yum. But if you choose a supermassive black hole, like the ones at the centers of galaxies, the gravitational force in them increases gradually. They can be millions of times heavier than the sun and much bigger, but the gravitational force on your head and your feet will be almost equal, and you will still feel comfortable. Who knows? Maybe if you manage to survive a fall into such a massive black hole, you'd find yourself in a completely different universe where different laws of physics apply. But so far, this is just a theory.
Empty space is not really empty. At least, that's what quantum field theory says. It's actually filled with tiny vibrations that can turn into virtual particles if they have enough energy. These virtual particles can produce packets of light with low energy called photons. Now, there's something every black hole has: an event horizon. It's a point of no return. That means once something crosses that point, it can never get away. Not even light. And there's an insanely strong gravitational force around the event horizon. Black holes survive by gobbling up gas and stars around them. In most cases, a black hole has a swirling disk of material that surrounds it, called an accretion disk. It glows brightly as all those things that come too close to an event horizon get heated up and torn apart before the black hole swallows them all. As material comes closer, it starts to travel and move faster and faster, going all around the black hole. This makes the accretion disk glow and, at the same time, outlines the shadow of the black hole, which is basically the very event horizon we're talking about. Black holes might even want to hide, but they do so awfully badly. According to Einstein's theory of general relativity, gravity bends and warps space and time. It means that the closer you come to this extremely powerful gravitational pull around the black hole, the more twisted space and time around it become. That's what Stephen Hawking was talking about nearly 50 years ago, and it doesn't stop there. He also suggested that if these particles find a way to escape a black hole, they steal some of its energy. And because of these thieves, the black hole loses its energy as time goes by until it, at one point, completely disappears. He suggested that black holes release energy in the form of thermal energy or heat, which is called Hawking radiation. And this radiation doesn't carry any information. It means that when a black hole evaporates, it destroys all information it had about the star that created the black hole. That way, we can't know what really happened. And it's kinda confusing because the laws of quantum mechanics say the information can't be destroyed. This conflict is something we call the Hawking information paradox. According to Hawking, all this information isn't really lost, but is stored in a cloud of all those zero-energy particles that surround the black hole. He called that soft hair. Now, there's this new study as a possible solution to this paradox. Maybe Hawking radiation is non-thermal. Instead of just releasing plain heat, it's possible the black hole sends out a message in the form of radiation. This message contains important information about the black hole's past, the stars that formed it, and other details we thought were lost forever. It's like a secret code that tells us all about the history of the black hole. But let's go back to Hawking's theory, where a black hole can eventually disappear. It says that not only black holes produce Hawking radiation, any object with enough mass can. Researchers actually studied a process called the Schwinger effect too. It's when an electromagnetic field creates strong distortions and in that way forms matter. They applied this idea to Hawking's theory of black hole radiation. What they found is that the radiation Hawking predicted can actually be created in places with different levels of gravity, not just around black holes. Here's the key. When there are massive objects, like stars or planets, they create a curving effect on space and time. This curving is there because of their strong gravity. Even if you're far away from a black hole, there's still some massive object somewhere around that creates the curving of space, which can make you feel like you're in that twisted space. It can create radiation, similar to what happens near black holes. It means that not only black holes can slowly evaporate, other massive objects in the universe can also lose their energy in the same way. If this is true, the energy of everything in the universe will slowly be drained away in the form of light particles. That means everything and everyone, including stars, planets, black holes, and us, share the same destiny and will all eventually fade away. This sounds scary at first, but even if this theory is true, it's not going to happen anytime soon. It would take way longer than the current age of the universe for a supermassive black hole to completely disappear. So, in the way we measure time, black holes are basically eternal. And stars could last even longer since many black holes formed after some giant star collapsed upon itself. Some others belong to a group called primordial black holes. Hawking, who became famous for talking about black holes, mentioned those ones as well. And the theory says they probably formed spontaneously in the early universe, not long after the Big Bang happened. Hawking realized that primordial black holes could have different sizes, from very light to very heavy. Really small ones would have disappeared by now because of Hawking radiation. There's a pretty cool idea that these primordial black holes could be dark matter. It's a mysterious substance that scientists think exists in the universe. It doesn't give off or reflect light, so we can't see it directly. Scientists think dark matter might explain why stars and galaxies move in strange ways, but we still don't have the tools yet to confirm whether these black holes really exist or if they're actually made up of dark matter or not. Hawking also explored the idea that our universe is just one of many universes. It's a concept called the multiverse. Some scientists believe it could be that any situation you can imagine in your life is happening somewhere in some other universe. Hawking didn't agree with that, so in his final paper, he proposed a new mathematical framework that made the multiverse finite instead of infinite. This means that there would be a limited number of universes rather than an infinite number. Another thing that's hard to test and prove, but at least he left us with something to think about. Believe it or not, time travel is not that impossible according to the laws of physics. Scientists have equations that suggest we could have something called closed time-like curves that might allow us to go back in time. Imagine going back to the most embarrassing moments of your life. Knowing what would happen, you could avoid them. But here's the tricky part. Going back in time could cause some big problems. It could create situations where things would happen in a way that doesn't make sense. Imagine you're walking down the street and meeting your younger or older self, or accidentally changing things that have already happened. Hawking was talking about this part too, and these are all things that made him concerned about time travel. He made a guess called the chronology protection conjecture. He suggested there might be a rule of nature that stops time travel from happening because it could create all these strange and confusing situations where we would just go back, fixing our wrong decisions rather than living in the present. Until we discover traveling through time without causing such disruptions, I guess all we're left with are life lessons and learning from our mistakes. In his last years, Hawking talked about the future of humanity, and we still don't know if he was totally serious. He mentioned a special particle called the Higgs boson that could cause a big bubble that could gobble up and eventually even destroy the universe. He also mentioned things like beings from other planets coming to Earth and conquering us, or robots becoming smart enough to take over the world. Some of his ideas turned out to be true, and time will tell if it will be the same with the others.